So, hi everyone. Let's say I give you some data points uh, in some real space. Let's say these are some of my data points, and you can assume these points may be in R2 or maybe in R3. If I ask you what is the shape of this data, so I have given you this data and I'm asking you what is the shape of this data. You can say that I can see that this, if I do a regression on this, I may get a line something like this, which is approximating this data, right? So one can say that this the shape of this data is a line. Okay. Now let me give you another set of data. Let's say you have data something like this. You have some data points here, some data points here, and some data points here. Now if I ask you what is the shape of this data, what is the shape of this data that I've given you? So through visuals, one can say that uh, I can see one ball or one patch of data here, one patch of or one circular kind of data here, and one small ball of data here. So three connected or the I'm by connected I mean those data points which are very close to each other. I am saying that those data points are connected, and since this data and point and this point is very far, so they are not connected, mm, which we can think of. So we can say that there are three connected clusters. So this is kind of thing we do in clustering algorithm. So uh, this kind of thing we do in regression tasks, and this is a clustering task, right? Now if I give you another data set, let's say data point are something like this. Now through visual inspection, you can say that this data set is having a circular shape. If I draw so we have a loop here. So we have a loop. So the shape of this data is a loop or a circle, right? Now again, uh, let's say this is one more type of data set which has something like this, which has orientation something like this. Now you can say that this data set is following some kind of shape of y, letter y, right? So through this experiment, what we can conclude? We can conclude that for a given data set, we can have any kind of shape, right? So each data has some kind of shape. So there is really famous quote that data has shape and shape has meaning. Now, what meaning a shape has, we'll discuss it. But first of all, uh, every data has some shape, and the data that I have presented here is quite small, so one can easily uh, guess the shape of this data without without using any complex algorithm, right? But in real world, in real world, we have big data, right? Too much data, lots of data is present. So for that very high volume of data, it's not easy to tell what is the shape of a particular data set, right? Because that's a huge data. We can't even plot that all data on this single uh, sheet, this single sheet of paper, right? So we want to analyze the shape of our data, right? we want the we want to know the shape of my data. And what is the problem? In real world we have the big data. It is not easy to plot all those points and see how what kind of shape this data uh, is having, right? What can be other problems which you can think of? What can be other problems which you can think of? Data is not always of two dimension or three dimension, right? So we can have high dimensional data. The data that I have presented here is a 2D data, right? So in real world, it is not true that you have a simple low dimensional data. We can have 6 dimension, 7 dimensional, or 10 dimension, or any kind of number of dimensions in our data. So so it is not possible to visualize that data. So if you can't visualize the data, then how can you know the shape of that data, right? So we can't find the shape of any data just by looking at it. So we need a general mechanism or some mathematical analysis to know the shape of my data. First of all, the shape that I'm using the word shape again and again and again. This shape is nothing but a topological feature. Okay, so um, when you look at any object, you can visually say that it has some hole. Like we in this loop we have one hole. We can say that it has some kind of void. Like if you have a hollow ball, in that we have void inside it, right? Or we can say that connected components in my shape, connected components. Like in this data set we have three connected components. Here we have only one, here also we have only one. So these kind of features are nothing but topological features. So these are my topological features. So in topological data analysis, we deal with topological features, and these topology features are associated with shape of my data. So what kind of shape is associated with this data? How many number of holes are in this data? How many number of connected components are in this data set? These are my topological features, and we want to do some analysis on that data, on these features. So doing analysis on topological features is nothing but topological data analysis. So analysis of these topological features is nothing but TDA, topological data analysis. And we need some algorithms, we need some mechanism, we need maths through which we can, if someone gives me a very high dimensional data or very high volume of data, it is not always possible to visualize that, or we look at the data set, we can't do that. So we need some algorithms uh, to do to find the topological features and then do some analysis on that, on those features, right? So this is what we study in this course of on topological data analysis. So more formally, we can say that topology is a mathematical approach which is used to study shape and structure of the data, and it also helps us to understand the holes, loops, and other problems in data which might not be apparent through traditional methods. In traditional method, what we do, we find what is the coordinate of that point, what is the distance between these two points. But these kind of traditional methods are not giving me any insight about the shape of my data. They are not telling me how the data is, how what kind of shape is associated with my data set. This Euclidean distance and the coordinate of those points are not giving me any kind of these insights. So these traditional methods are not sufficient. So that's why we have came across this new branch of mathematics, that is topological data analysis, and it is particularly useful whenever when we are dealing with very high complex data and which is of very high dimensions. Great.